In this lecture, I will talk about universal conditional statements, and then we will talk about examples. There are 3 to 4 examples we will discuss to clarify this topic, universal conditional statement. So what is universal conditional statement? Sometimes it is more important to pay attention at the words used in the topic. Here, for example, if you want to understand what this will be about, so we see that over here there is one word which says that universal, and we know that it is about statement. And the second word that describes this statement is conditional. So it means that these statements are those statements where something is universal as well as conditional. In the previous lecture, we saw that universal has a keyword, for all, or maybe only all, or every. And there can be some other keywords as well. And we also saw that conditional has a keyword if then. So it means that if we have something universal and then the condition holds, that condition will hold for every element in the set. So formally we define universal conditional statement. It is a statement. It is a statement. It is a statement that both universal and conditional. Let me just give you a very simple example, and then we will talk about some other examples as well. For every animal example, so let me just write example over here. For every animal A, since this statement contains every, so we have a universal statement, a part of that statement which is universal. If A is a dog, then we can conclude that A is a mammal. So this is a universal conditional statement. It has 3 components. In fact, it has 2 components. The first component is universal. Then the second component is conditional statement. I hope you understand this concept. Let me just solve some examples. This says that if we have such a statement over here, we can rewrite this statement in a different way. This statement says that for every real number x, if x is non-zero, it means that it can be negative and it can be positive, but it can never be zero, then x square is positive. That's the statement given in this question. The idea of this example is to rewrite this statement in a different way, which is given in parts A to E. So we can write, for example, the answer of, we can fill in the blank, in fact. If A is a real number, which is non-zero, then its square is positive. That will be the answer is positive. So we have rewritten the given statement in part A. Now the same statement can be written as part B, and we have to fill this empty space over here. So it says that for every non-zero real number x, what would be the answer? X square is positive. Okay. In C part, if x is dash, then something is there. If x is, we can write, what is the condition on x? If x is a non-zero, so it means that if x is a non-zero real number, then x square is positive. D part, for example, the square of any non-zero real number is positive. All non-zero, so all is the universal statement. All non-zero real number have positive squares. So here, from this example, we learn how a one statement, which is universal conditional statement, can be written in different ways. Let me just write this example more of a mathematical way. It says that for all, now I am talking about the general statement of universal conditional statement. It says that for all x, if some t, which is a function of x, then q is a function of x. That's how you write the general statement in mathematical way. This symbol over here, we will talk about that in future. This symbol over here says that for all. This is one of the compact way of writing universal conditional statement. Example, for all real numbers x, if x is greater than or equal to 1, then x square is greater than or equal to 1. So in the first part we have for all, and in the second part we have if and then. So we can write it as for all x belong in mathematical form or symbolic form, if for all x belong to R, if x is greater than or equal to 1, then x square is greater than or equal to 1. Another example, for all shapes for all shapes if the shape is a square. If shape is a square, then it has four sides. Then it has four sides. So we can see that out of all the shapes, for all shapes, and it is true for all shapes, if the shape is a square, then it has a four side. How can we write this symbolically? For all x, if square x, then four sides depend on x. For all x, x here it is the shapes. Okay. The last example. For all integers, for all integers, if n is even, then n square is even as well. This is an interesting example. So symbolically, we can write this as for all n belong to z. N is coming from integer, and if even n is even, then n square is even as well. That's how you write symbolically, or maybe in a natural way, if n is even, then n square is even. So it is almost similar to what I have written over here. Okay. So this was all about universal conditional statement. Thank you for watching.